Very good evening, all of you. Hope you all are doing well. Let's start with today's session. Quick recap of yesterday's session. Yesterday we discussed about arithmetic operator. I hope you're clear with it. Then we discussed comparison operator and then logical operator. I hope about logical is clear to you, right? I told you, like if you are writing A and B, right? So both should be true for the result to be true. If you want the result as true, then A also should be true and B also should be true. Getting? And if you're having OR operator, A or B, then in that case, either of them is true. If A is true or B is true, the result is true, right? And then NOT operator. It will just give complement of A. If A is true, NOT will give false. If A is false, NOT will give true, right? Only thing is, if this A and B is not Boolean, if they are not Boolean data type, then what I said, in case of AND, it will give you the last Truthi value. Last Truthi value. Okay. Last Truthi value means when all are true. When A is also true and B is also true, then the last truth value is returned. And otherwise, the first false value. The first false value or last Truthi value if all are true. In case of ORing, the opposite. It will give you first Truthi value, first Truthi or last falsy value, last falsy value. Right? So last falsy value or first Truthi in case of OR. So that examples also I have told you last time. If you remember, just quickly we'll go to idle. Okay. Like example, I've written double quote Ram and if I'm writing double quote Sita. So in this case, double quote Ram is treated as true. It will be treated as true because according to Boolean value, it is a non-empty string. Non-empty string means true. As it is true, it has to go ahead. Sita is also true. Both are true, then in that case, it will return the last Truthi value. So which is the last Truthi value? Sita. It will return Sita. Getting guys? And if the same thing if you are writing in OR. So what it will do? First Truthi value. First Truthi. So in this case, who is the first Truthi value? Ram. So it will return Ram. Getting? And in this case only, if it is false, so whichever is that first falsy value in AND. Okay? Like if first I'm writing Ram, then suppose I'm writing empty string, and maybe after that I'm writing 100. So Ram is true. As it is AND, it has to check the next one. But next one is double quote, empty string. Empty string is false. It will stop here, and that first false it will return. Obviously, it's not going to go ahead. Getting? Does it return the first falsy? Very simple rule it is. In case of OR, it returns the first Truthi. In case of AND, it returns the last Truthi. If all are true, last true. Getting? And if all are false, it will return the first false in case of AND. See here, this was the first false. That first false it has returned. And in ORing, first Truthi. But if all are false, then it will return the last false. Huh? Remember, see, like I'm writing zero or double quote or, and I'm writing, okay, only this thing. So now zero is false. It will come and check. Empty string is also false. Now it will return the last false, and last false is empty string. So it returns empty string. So I hope it is clear now. Okay. At the end,
Yes.
few more trace outputs you'll see, you'll get it. Like, okay. Then we have to move to next operator, that is identity operator. It is just to check whether two objects are representing same memory. Means, are they representing same memory? Meaning, are they pointing to the same address? Getting? And the operator is operator, is. And you can use is not also. Is not is to check opposite. Getting? Is not is also there and is also there. So A is B. A is B. It's a binary operator. It's going to work on two operand. It works on two operand. It's a binary operator. It will just check whether the address of A and address of B is same. In short, are they both representing same object? A is also referring to the same object and B is also referring to the same object. So if both are referring to the same object, is will return true. Getting? Otherwise, it will return false. Okay? And is not opposite. A is not B. Means if A and B are having different addresses, then true. And same addresses, then false. Because you are doing not opposite of it. Getting? So it is more easy to check whether both the objects are referring to the same memory by is, instead of finding out the address. This also you can do. ID of A. How do you get address of any object in Python? Using ID. ID of A. How you'll get address of another object B. And then can you compare these two addresses using double equal to? Getting? So instead of doing this lengthy operation, getting the address of A, then address of B, and then comparing that addresses, instead of that, Python has given directly is operator. Directly you can say A is B. Okay. So if A and B both are representing same addresses, it will give you true, otherwise false. Okay, so that's simple this operator is. So identity operators are used to check whether two objects represent same memory location. Getting? Okay, so suppose I'm writing A equal to 10, suppose, and I've written B equal to 10. So you know the addresses of A and B are going to be same because their values are same. I hope in the past we have discussed all this. They come under that pooled range -5 to 256. So they are not two different objects. A also refer to the same 10 and B also refer to the same 10. Isn't it? Okay. So in ID of A, if you check, this is the address. And if I check ID of B, the address is same. Isn't it? So if I write ID of A double equal to ID of B, you'll get true. The address of A and the address of B is same. So instead of comparing this way, Python says directly you can compare A is B. Still you'll get answer same. Understanding? But if they're having different addresses, like in A it is 10, but in B if I'm putting 20. So obviously now they're referring to different addresses. A will refer to object 10, B will refer to object 20. Isn't it? And now if I check A is B, it will give you false. And their addresses also will be different. Already you know this is the A's address. And if you check B's address, now it is going to be different. Okay, see. And as the addresses are only different, obviously A is B is going to be false, right? Now this is not only applicable for integers, it is applicable for other values also. Okay? So in short, what it is checking, that is clear to you, right? See here, X is Y. It is just checking whether X is referring to the same address where Y is referring. It is just confirming that X and Y, are they both referring to the same memory? If they both are referring to the same memory, it is true. Otherwise, false. ठीक है,
Sir, it's just the memory location, right? Not the
the
variable
value.
value
No,
assigned to the variable.
it is not comparing the value. If you want
Ah,
to compare value, directly you can compare it by x double equal to y.
okay.
When you write x double equal to y, at that time it is not comparing the addresses, it is comparing the value at that addresses.
So it just checks the object which is in the memory, right?
Right. So it is just checking whether x is referring and y is also referring to the same memory. Means here whatever the address is kept, getting? So is the address of x and y same? So that's what I showed you in the harder way also. No? You can check whether A and B's address is same or no. You can check it by this way also. This is the harder way. You're finding address of A, you're finding address of B, and then you're comparing those addresses, right? So instead of doing this in a lengthy way, Python says directly you can use is operator. It is more close to English. Python says express as if you are expressing something in English. So you're just checking whether A is B. A is B means whether address of A is same as address of B. Okay? And the opposite, if you want, then you can check is not. Is not will do the opposite. It will check whether X and Y are referring to different memory location. So if they're referring to different, is not will give true. And if they refer to same, is not will give false. Understanding? Opposite it will do. See, now the addresses are different. So if I write A is not B, it will give true. Why? Because they are having different memory locations, right? Okay, so I hope it is clear to you. Right or no? You can give me quick confirmation so that we can move with the next operators. Many
Yes.
more in Python you have to learn. So many things you have to learn. Okay. Next is membership operator. Now, membership operator can be applied only on iterable objects. Getting? Now you'll say, what are iterable objects? You can say iterable, or you can call it as collections. Okay. Some languages call it as collection. In Java, sorry, in Python, they call it as iterable. You can call it as collection, or you can call it as group object. Okay. Or you can call it as sequence. So many names are there. Like string, if you consider. So string is a sequence. It is a sequence of characters. Okay. List you can take, or tuple you take, set you can consider. You can consider set, or you can consider tuple. You can consider a dictionary. All are iterable. Now you'll say iterable means what? It's an object which is grouping many objects. An object inside which there are many other objects kept. Best example, like if you take your office bag or your college bag is itself an object. That bag is itself an object. And inside that, many other objects are kept. Right or no? Your laptop is kept, your charger is kept, your power bank is there, your tiffin is there. Then maybe many more things. Your water bottle, pen sometimes, notebook rarely. So all these things are what? Objects. Isn't it or no? These all things are what? Objects, and they're kept in another object, which is bag. So that bag acts like a container. It acts like a collection. It acts like a container. Okay, it acts like a group object. And you can also call it iterable. Why? Because you can visit these items one by one. Whenever you are able to visit the items one by one, then we call it as iterable. One by one, you can retrieve them. If you want to make this bag empty, so one by one values you remove from it. Okay, so means what? You're iterating it, you're visiting it, you're traversing it. So those objects are called as iterable objects. So we'll be learning in detail about iterable objects in the third module when we'll complete this first module. Then second module is all control flow and all. Then in the third module, we'll be learning about all the data structures and all. Okay, so there will be learning what is list, what is tuple, what is dictionary and all. Now we just have to learn this operator. Okay. Now this is also a binary operator. It's a binary operator. It will operate on two operands and it will always return Boolean answer, true or false. So what it does, it just checks whether an element is present in, so in is that membership operator. In is the membership operator. So it is checking whether that element X is in the iterable object. Right? So your right side will be your iterable object, left side will be the element. It will just check whether this element is in this iterable. If it is there in the iterable, it will return you true. Otherwise, it's going to return you false. Getting that simple it is. It's making your work easy. Python has tried to make programmers work lesser by pulling that work from programmer and they are doing on their own in the background. It is abstract, hidden. The same thing if you are a C programmer or something, C programmer or C++, you will write a logic to check whether that X is there in the iterable or no. You will one by one take the elements from it, then match it with X. If it matches, then you'll return true. All that logics. Here also in the background, the logics are generated, but all are hidden to you, abstract. They are saying just use this operator. The background work we will do. Get it? So it is just checking whether this element is there in the iterable or no. This concept in set theory and all we have learned. Discrete maths, 11, 12, you might have studied discrete mathematics. We used to write like this: X belongs to A, where A is a set of elements and X is the element. So if X is present in it, we used to write like this. Getting? If absent, like this. So here also same thing. X in A, where A is the iterable. And opposite you want to check, then not in. You'll just write not in. Getting? So if X is not in A, it will give true. And if X is in A, then it will give false because we have written opposite. Okay. So concept is clear. I'll give you demonstrations. Don't worry. Membership operators are used to check whether an element is present in the iterable object or not. Whether the element is present in the iterable object or not. That's all it is checking. Right? See here, in. If I write X in Y, so in this case, obviously Y is a iterable and X is an element. So if this X is present in Y, it will give you true, otherwise false. Opposite. If X is not in Y, true. And if X is in Y, then false. It is opposite, not in. So you can read it, returns true if the element is present in the iterable. Here it returns true if the element is not in the iterable. Okay? I'll give you a quick example. Okay, like what I'll do is see, I'm just checking whether E in hello. Now this is allowed. Why? Because hello is a sequence. As hello is a sequence, you can traverse it character by character. So it comes under iterable category. It is allowed to apply. Now is E in hello? Yes, therefore true. If you try to check whether Z is in hello, is Z is in hello? No, it will give you false. Now this I did it on string. You can do it on list or anything. See, I'm creating a list L equal to 10, 20, in between RAM, 4.5, some complex number, getting any Boolean value, whatever, 100. This is a list of elements. Okay. And now I'm checking whether any of the element is there in that L or no. Like I'm checking whether RAM in L. So is that string RAM present in L? Yes, it will give you true. Getting? Same way 4.5 in L. Yes, it is present, therefore true. If I'm checking Sita in L. So as Sita is not there in L, it gives you false. Is string CETA present in L? No, it is giving false. I hope you got it. Is it? Quick confirmation you can give, guys.
Yes.
Sure, no? Others also. Others and those who have joined recently, please in pipeline,
Yes.
keep watching the videos also so that everything is matched, right or no? So you can come in the flow, okay? So try to watch it. And hardly 1 hour videos are there. So if you find out 1 hour in whole day and check all those things, it will be better for you only. So that you come in the flow, whatever is going on, it becomes easy for understanding, right? Let's move ahead. Okay. We will move ahead in the next category, that is bitwise operators. Okay. Now some criterias about bitwise operator. Now bitwise operators are unary also, binary also. We have unary bitwise operator also and binary bitwise operator. Both are there. We'll be learning that. First criteria is that these bitwise operators are only applicable on integers. Means you can apply them only on integers. Now integers means boolean allowed. Why? Because internally boolean is 0 and 1. True is 1 and false is 0. Therefore boolean okay. Integer allowed. You cannot do bitwise operations on a floating value, string value, complex number, not allowed. It will give you an error. Okay? First that you have to remember. That is the first important criteria, that bitwise operators operate only on integers. Okay? If you try to do it on any other, it is going to generate an error. Okay? Now, next, what I want to tell you is now already it is confirmed that these operators operate only on whole numbers, that is integer. What it does is it considers the memory representation of the operands. Whatever, like this is a bitwise operator, unary, tilde A. So it will take A's memory representation. Or this is a binary one, A and B. So it will take A's memory representation and B's memory representation. Whatever value of A is there, its memory value. Whatever B, its memory representation. And you know what will be the memory representation of A and B as they are integer? Will they be in binary form? Yes or no? In memory, everything is kept in the form of
Zeros and ones.
zeros and ones. That is binary, right? So it will take A's memory representation, B's memory representation, which is binary, and then it will operate on the individual bits. Whatever A's memory representation is 1, 1, 0, 0, 1, 0, whatever. B's representation is 1, 0, 1, 0, 0, 1. And then it will operate on the individual bits. If it is a binary, then corresponding bits. If it is unary, then only that single operand. But the rule is consider memory representation of the operands. And what is the memory representation of the operand? It's binary form. And then it will operate on the individual bits. Get it? Like this, corresponding bits 0, 1, 1, 0, 0, 0, 0, 1, like that. Okay? Now, that basic thing, it is clear. Only one thing I want to tell you or just check whether you know it. Some people may be knowing, like maybe in the academics, like in their computer science course, or those who have already completed graduation, then they might have done it somewhere in digital electronics or whatever. Might be knowing. Okay, if we are knowing, well and good. No, I'll just recall it. Now, you know it. Whatever value is, it's equivalent binary. Like if the value is 5, then its equivalent binary will be there. Like 1, 0, 1. Is it right? 2 raised to 0, 2 raised to 1, and 2 raised to 2, if I consider. So 2 raised to 2 is 4, and 2 raised to 0 is 1. So 4 plus 1 is 5. Getting? So for simplicity, if I'm considering a byte, byte means 8 bits. 4 bits make one nibble. This is one nibble. This is another nibble. 2 nibbles make one byte. So this is 5's binary. Maybe other value is like 9. So maybe 9's binary. 1001. Getting? Now this is 2 raised to 3. Now 2 raised to 3 is 8. So there I am taking 1. Now to make 9, I need one more. 2 raised to 0, 1. So 8 and 1, 9. This is okay. Now the value is positive, it's binary. Positive, it's binary. But what about negative? If the value is negative, then how negatives are stored in computer's memory? Getting? That is the question. So I assume many might be knowing already, but just I'm recalling it or I'm telling it again, just try to confirm. Okay. Always remember negative values are stored in computer's memory as 2's complement form. Actually, this apostrophe is not there. If I consider English as a language, then we don't need. Only you have to write 2's complement form. Okay. 2's complement means what? Okay. So it is 1's complement plus 1. Now you'll say, what is 1's complement? 1's complement means just toggling 0 as 1 and 1 as 0. Make 0 as 1 and make 1 as 0. So when you toggle the bit, just you're toggling the bit, it becomes 1's complement. And in that, when I add 1, it becomes 2's complement. No need to go for this so much lengthy process. I'll tell you how to directly find 2's complement. I'll give you the procedure. Okay? Not invented by me. It is from 30 years back when my teacher taught. It is recorded. Not even 30 means you can say before that 4 years, right? So when my teachers taught, it is still there and the same way I'm following. Okay, how to find 2's complement. But first, what you remember that all positive numbers are directly stored in their binary form. Correct? But if it is a negative number, then they are stored in 2's complement form. Okay? I hope you will remember this principle. All positive numbers are stored in all positive numbers are stored directly in binary. But if it is negative, then it is stored in 2's complement form. Okay? So examples, suppose like I'm telling this is minus 9 and represent minus 9 in 2's complement form. Minus 9 in 2's complement form. So first you will make plus 9. Okay, first you represent plus 9 in binary. This is plus 9 in binary. And with this, you should observe, see, this is the first bit called as LSB. LSB means least significant bit. And this is the last bit called as MSB, most significant bit. Most significant bit, least significant bit. Always you should see this most significant bit, which is there, the last bit, is also called as a sign bit. And from this only we can recognize whether the number is positive or negative. ये जो लास्ट बिट होता है इसी से हम तय कर सकते हैं कि नंबर पॉजिटिव या नेगेटिव. देखो लास्ट बिट पे अगर 0 है, MSB पे 0, तो इट इज अ पॉजिटिव नंबर. And here in MSB, if you get 1, it is always a negative number. Getting? तो देखो अभी जब मैं इसका 2's complement बनाऊंगा तो ऑटोमेटिक यहाँ 1 आएगा. इससे ऑटोमेटिक कंप्यूटर को रिकॉग्नाइज होता है कि वो नंबर नेगेटिव है. ठीक है? तो फर्स्ट आई हैव रिप्रेजेंटेड हुज बाइनरी, पॉजिटिव बाइनरी, +9. +9 का बाइनरी है, बट हमें +9 नहीं चाहिए, हमें -9 का बाइनरी. एंड अभी मैंने बताया हाउ डू वी रिप्रेजेंट नेगेटिव नंबर्स इन कंप्यूटर्स मेमोरी? 2's complement. So you have to take 2's complement of this traditional process, what I said, take 1's complement, then add 1. The easiest way is from LSB till you don't get first one, keep it as it is. जब तक first one नहीं आता है, तब तक as it is रखो. And after that you do 1's complement. Understanding? तो नाउ सी फ्रॉम LSB द फर्स्ट वन, तो ये फर्स्ट वन ही है तो रखा एज इट इज, इसके पहले जीरोस रहते तो भी वो वैसे ही रहेगा till first one as it is, and after that you'll complement. See, 1 1 0 1 1 1 1. This is actually whose binary? Can you tell me? This is actually in computer's memory. Whose binary? Minus 9.
-9.
Correct? So always remember positive numbers, direct binary. Any positive number, its direct binary is created. But what about negative numbers? Whatever the positives binary, it's 2's complement. जो भी पॉजिटिव का बाइनरी था उसका 2's complement. एंड ये फिर किसका बाइनरी बन गया? नेगेटिव नंबर का. अंडरस्टैंडिंग? ठीक है. एंड देख रहे हो कि दिस इज द बाइनरी ऑफ -9 एंड कैन यू सी द साइन बिट इज 1. Whenever sign bit is 1, for computer the number is negative. And whenever the sign bit is 0, for computer the number is positive. Always. ठीक है? So first of all, that thing is clear. Then we can move ahead with the operators which come under bitwise category. Getting? Any binary, like if I'm giving a 0, 1, 1, 0 and 1, 0, 0, 0, and I'm telling find its 2's complement. इसका 2's complement बनाओ. तो क्या करोगे? 0, 0, 0, 1. LSB से जब तक पहला 1 नहीं आता है तब तक as it is. एंड फिर कॉम्प्लीमेंट करना है 1 0 0 1. तो ये जो नंबर था इसका ये 2's कॉम्प्लीमेंट है. 2's कॉम्प्लीमेंट बहुत इजी टेक्निक है. फ्रॉम LSB till the first one, from LSB till the first one, keep it as it is, and after that do 1's complement. After that just toggle the bit, 0 as 1, 1 as 0, 1 as 0, 0 as 1. ठीक है? Yes or no? So you can give me confirmation so that I'll move ahead with all the operators one by one.
Yes,
Yes,
sir.
sir.
Now, coming to the first operator, that is tilde A. Tilde A, it is just going to toggle the bits. Whatever that A is, it's binary. जो भी A है, उसका binary लेगा, and वो binary के bits को toggle करेगा. 0 को 1 बनाएगा, 1 को 0. इसका एकदम शॉर्टकट टेक्निक है आंसर ढूंढने के लिए. There's no need to go and check the binary and all. Those who are very curious about memory में कैसे होता रहेगा, I want to find out and all. Then you can find out the binary and do all that things. डायरेक्ट अगर सिर्फ आंसर में कंसर्न्ड हो तो टिल्ड ऑफ ए का आंसर हमेशा आएगा माइनस ऑफ ए प्लस 1. चाहिए तो मैं एक एग्जाम्पल लेके मैं प्रूव करके दिखाता हूं. करेक्ट? tilde of A is always minus of A plus 1. आप करके भी देख सकते हो. करेक्ट? जैसे देखो अगर मैं लिख रहा हूं प्रिंट, ठीक है, tilde of 12, tilde of 12, तो 12 plus 1 कितना है? फटाफट बोलो. 12 plus 1 is how
30.
much? 13. And 13 को माइनस साइन से. 12 plus 1 is 13 and 13 का माइनस, तो minus 13. You can check also answer. Is it minus 13?
Yes.
ओके. कुछ भी लो, लाइक ए मैंने अगर दिया है -12, अगर ए ऑलरेडी -12 दिया, -12, तो बताओ -12 प्लस 1 कितना? -12 प्लस 1. इज इट -11?
Yes.
एंड -11 का माइनस कितना बनेगा? 11. दैट्स ऑल. प्रिंट टिल्ड ऑफ -12. विल इट गिव 11? -12 plus 1 is -12 plus 1 is -11 and already बाहर माइनस है. ठीक है? Does it give 11?
Yes.
So I hope this formula is clear कि जब भी टिल्ड ऑफ ए ढूंढना है तो डायरेक्ट क्या करोगे? माइनस ऑफ ए प्लस 1. बट प्रूव करते हैं, एक एग्जांपल लेके जस्टिफाई करते हैं. ठीक है? We will take one example. First what we'll do, we'll take a as positive. देखो tilde of 12 लेते हैं. तो टिल्ड ऑफ 12 का क्या आया था आंसर अभी जस्ट नाउ? 12 प्लस 1 13, 13 का माइनस 13, इज इट और नो? देखो टिल्ड ऑफ 12 माइनस 13, वी विल क्रॉस वेरीफाई. फर्स्ट कैन यू टेल मी बाइनरी ऑफ 12? 0 0 0 0. This is 2 raised to 3 8, 2 raised to 2 4, 8 and 4 12, बाकी दो 0 0 है ना. 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 3 is 8, 2 raised to 2 is 4, 8 and 4 is 12. हो गया, ये बाइनरी हो गया. ट्रेडिशनल मेथड्स जो होता है ना, वो डिवाइड बाई 2 एंड फिर कलेक्ट द रिमाइंडर, लेंदी वे. हम लोगों को अभी शॉर्टकट टेक्निक्स चाहिए, तो अप्रोक्सीमेशन करके टोटल निकालना है. तो ये 8 and 4 12 है. दिस इज 12. Is it 12 in binary? Now you are doing tilde of 12. आपको tilde of 12 करना है. अभी 12 tilde क्या करता है? हर एक बिट्स को टॉगल करता है. It is just going to toggle the bit 1 1 0 0 1 1 1 1. Can anyone tell me, is computer going to give directly decimal of this answer, or it is going to convert it to 2's complement and then give its decimal with a minus sign? ये अपना
As it
12 था.
it will
हाँ.
convert it into 2's complement and give the
Yes,
answer.
yes, it will convert it to 2's complement. Why? देखते हैं. मैं माउस भी वहां घुमा रहा हूँ, इससे समझना चाहिए.
MSB
Starting
can
हाँ, हिंट देते रहता हूँ. इफ यू सी केबीसी, केबीसी जैसी चीजें देखनी है, you should watch KBC. You should not watch the spoiling Instagram. वो Instagram पे जो चल रहा है एंड जो भी सोशल मीडिया के न्यूज चल रहे हैं और दिमाग खराब करना है, उससे अच्छा केबीसी देखो. Mr. Amitabh Bachchan, you should see how that person is, how he manages the show, how he handles the people. And उतना ही नहीं, क्वेश्चंस, अपना नॉलेज भी बढ़ते रहता है. देखो केबीसी में अगर वो पर्सन है ना, गलती करने वाला रहता है, तो ही गिव्स इंडिकेशंस. अगर देखा रहेगा तो कि आप श्योर है क्या, रियली आपको लगता है क्या, ऐसे वो इंडिकेशन देते हैं. अगर आपने उनका प्रोग्राम बहुत ध्यान से देखा रहेगा तो यहाँ वो भी, मैं भी वही करता हूँ. मैं ऐसे माउस घुमाता हूँ, ऐसे इंडिकेशन देता हूँ. तो कैन यू सी एमएसबी? एमएसबी पे क्या है? 1. And as it is 1 for computer, the number is negative. And as for the computer, the number is negative. It will not directly convert to decimal. It will first convert to 2's complement. इसका पहले 2's complement बनाएगा, जो आएगा उसका डेसिमल, बट साइन माइनस ही. क्यों? डायरेक्ट डेसिमल जब आता है ना तो पॉजिटिव, 2's complement करके जब डेसिमल आएगा तो हमेशा आंसर नेगेटिव. So now can you tell me what will be the 2's complement of it? 1. From LSB till we don't get first one, I have to keep it as it is. 1, then 0, 1, 1, 0, 0, 0, 0. Okay? Now decimal of this. Can you tell me this is 8, this is 4, and this is 1. Right or no? So 8 and 4, 12, and 1, 13. But will it give 13 or will it give minus 13?
minus.
Because we have not found out the decimal of the original answer. ओरिजिनल आंसर का जब भी डेसिमल होता है तो वो डायरेक्ट पॉजिटिव. ओरिजिनल आंसर का 2's कॉम्प्लीमेंट करके फिर डेसिमल बनाते हो तो वो नेगेटिव ही होना चाहिए. करेक्ट. एंड बेसिकली हम ओरिजिनल आंसर का 2's कॉम्प्लीमेंट करते ही क्यों है? बिकॉज द साइन बिट इज 1. अगर अज्यूम करो साइन बिट क्या रहता था? 0. तो देयर वाज नो नीड टू कन्वर्ट इट टू 2's कॉम्प्लीमेंट. डायरेक्ट डेसिमल करो. जब डायरेक्ट डेसिमल होता है वो हमेशा पॉजिटिव. ठीक है. तो कैन यू क्रॉस वेरीफाई? देखो आंसर कितना है. माइनस 13 ही आया ना यहाँ. यस नो?
Yes, sir.
राइट. एंड अगर मैंने कहा टिल्ड ऑफ माइनस 12, देखता है टिल्ड ऑफ माइनस 12, तो पहली बात माइनस 12 कैसे रिप्रेजेंट करोगे कंप्यूटर्स मेमोरी? पहले +12 दिखाओ, +12 अभी जस्ट नाउ देखा हमने, 0 0 0 0, एंड एट एनी पॉइंट इफ यू हैव डाउट यू कैन आस्क मी गाइस, ठीक है? क्योंकि ऐसा हो सकता है कि कुछ लोगों को समझ रहा है एंड आई एम गोइंग विद देयर फ्लो, बट सम आर लैगिंग एंड सम आर नॉट अंडरस्टैंडिंग. नो प्रॉब्लम, यू कैन अनम्यूट एंड यू कैन आस्क मी. इज दिस बाइनरी राइट? 12, ये 12 का बाइनरी राइट है, 8 and 4 12, बट हमें 12 नहीं चाहिए, -12 चाहिए ना? यस नो? So how is -12 stored in computer's memory? ये -12 कंप्यूटर के मेमोरी में कैसे स्टोर होगा? +12 का,
2's को.
चलो, हाँ, +12 का 2's कॉम्प्लीमेंट. सो 0 0 1 0 1 1 1 1. This is actually -12 in computer's memory. कंप्यूटर के मेमोरी में ये स्टोर्ड है, ये मैसेज दिख रहा है, ये स्टोर्ड नहीं है, ये है, बिकॉज -12 पे काम कर रहे हो ना आप लोग. गेटिंग? एंड देखा है इधर साइन बिट देखो 1 है, इससे पता चलता है कि इट इज नेगेटिव. नाउ आई हैव टू डू टिल्ड ऑफ -12. मैंने टिल्ड ऑपरेशन -12 पे लगाया, राइट? तो हियर विल इट टॉगल ऑल द बिट्स? टिल्ड तो टॉगल करता है ना बिट्स को, 1 1 0 1 0 0 0 0. ये आ गया आपका रिजल्ट टिल्ड ऑफ -12 का, -12 का टिल्ड करके ये रिजल्ट. कैन यू टेल मी इन द रिजल्ट इज द साइन बिट 0?
Yes.
Means for the computer the number is positive or negative?
Positive.
Positive. So is it going to do 2's complement or direct decimal?
Direct decimal.
Direct decimal.
Very good. So you got it. Concept समझ में है. अब बताओ ये कितना है? 8. ये कितना है? 2. ये 1 है. कितना टोटल होगा? 8 and 2 10 and 1 11. तो हमें 11 ही मिला था ना यहाँ. तो ये जस्ट प्रूव करने लिए किया. एक्चुअली व्हेन इन इंटरव्यूज एंड ऑल इन द एमसीक्यूज या फिर अभी जो एकेडमिक्स में जा रहा है, तो मेनी टाइम्स यू हैव दैट इंटरनल एग्जाम्स एंड ऑल, दैट टाइम दे गिव यू ऑल सच ट्रेस आउटपुट क्वेश्चंस. तो दैट टाइम नो नीड टू गो एट ऑल दिस लो लेवल एंड ऑल, डायरेक्टली फॉर्मूला वापरो. क्या फॉर्मूला मैंने दिया? टिल्ड ऑफ ए इज ऑलवेज माइनस of a plus 1. कोई भी वैल्यू लो, you take any value and you check. Getting? Quickly बताओ, if I write tilde of 23, what you are going to get? Fast बताओ, फिर मैं बाइनरी ऑपरेटर्स को मूव करूंगा.
-24.
-24, 23 plus 1, 24, sign -24. And if I would have given tilde of -23,
22.
plus 22. Okay, so the concept is clear. Now we will move to the other three, and then still two more are there. Next three I'll tell you. That is and. These are binary. Yeah, now they are binary operator. Binary means they are going to work on two operands: A and B, A or B, and A XOR B. XOR. Caret sign. इसको caret sign भी कहते हैं. So A XOR B, A or B, and A and B. They have different precedences. Remember, precedence, priority. Priority is different. Like if there is one expression in which all are involved, remember tilde is having higher precedence. It is unary. As it is unary, it is having higher precedence. Then and, then XOR, and then OR. Please remember that. At the end, I am going to give you one table. In that table, all the operators are arranged according to priority. Priority के हिसाब से arrange किया है. मैं एक लास्ट में टेबल दूंगा. ये अभी लास्ट कैटेगरी रह गया हमारा ऑपरेटर का, तो वो पूरा टेबल दूंगा, आपको पता चलेगा. But remember, AND is having higher, then XOR, and then OR. Now how they work? In case of ANDing, when both the corresponding bits are 1, then only the result is 1. अगर मैं लेता हूं A and B, और A की और B की corresponding bit 0 है, A की 0 है but B की 1 है, A की 1 है, B की 0 है, and दोनों की 1 है. Getting? So in case of ANDing, when both the corresponding bits are 1, then only you will get the result 1, otherwise 0. तो देखो इन दोनों में से एक कोई तो 0, एक कोई तो 0, एक कोई तो, इसलिए 0. When both the bits are 1, you get the result 1. ठीक है? Very simple rule. ORing. In case of ORing, when any of the bit is 1, the result is 1. Any. में दोनों 1 रहेगा, एक भी कोई तो 1 रहेगा तो भी चलेगा. Here you'll get 0, 1, 1, 1. Do you agree? 0 or 1, 1, 1 or 0, 1, 1 or 1. Sorry, 0 or 1, 1, 1 or 0, 1, 1 or 1, 1 only. Coming to XOR. In case of XOR, when both the bits differ means you're understanding they are not same. Means if one is 0, the other is 1, and vice versa. Then only 1, otherwise 0. Getting? See here. Here you'll get 0, here 1, here 1, here 0. Why for this two only 1? Because they differ. एक 0 है तो एक 1 है, एक 1 है तो एक 0 है. दोनों बिट्स अगर डिफर करते में डिफरेंट है तो ही 1. बट जब दोनों बिट्स सेम है, जैसे 1 1 0 0, then the answer is 0. Correct? Okay. So are these operators also clear to you? Then two more are remaining, that is shift operator. But before that, if these three are clear, okay, we can just take one quick example on it. Like suppose I'm giving 15 and 23 suppose. Here also negative is possible. एंड अगर नेगेटिव है तो आपको पता है, अभी मैं वापस नहीं बताऊंगा. नेगेटिव है तो उसका 2's कॉम्प्लीमेंट लेगा. तो 15 and 23, 15 और 23, 15 XOR 23. ठीक है? 15 and 23, 15 or 23, 15 XOR 23. We will find the answer. Instead of directly typing in that environment and then seeing the result, you start using your brain less. So paper and pencil, getting mental maths, which is our Indian origin. India का Vedic maths, ये mental maths पे ही है. And the whole world is learning, but we people are only not fascinated with it. Getting? So 15 and 23. 15 का binary पहले बताओगे? 15. Okay. Is it going to be 1, 1, 1, 1, and फिर रिमेनिंग 4 zeros लेता हूं. बोलोगे आपको इतने सालों से वो बाय हार्ट हो गया रहेगा, तो नो प्रॉब्लम, यू पीपल कैन टेक योर टाइम एंड फाइंड आउट. सी दिस इज 1, 2 raised to 0 1, 2 raised to 1 2, 2 raised to 2 4, and 2 raised to 3 8. है ना, ये 0th बिट है. तो 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 3 8, 2 raised to 2 4, 2 raised to 1 2, 2 raised to 0 1. Add करो, देखो 8 and 4 12, 14 and 1 15. Is it 15? Now let's see. You people tell me about 23. Am I supposed to go to the next one, that is 16?
Yes.
Okay, तो ये 1 ले लेता हूं. 23 बनाने के लिए और कितना चाहिए? 16 हो गया, तो और 7 की जरूरत है ना शायद. 16 plus 7 23 बनता है. तो 7 4 2 1 7 ही बनता है ना guys. 4 2 and
Yes.
1. So I'll put just 0 here. Done. Now this is 23, this is 15. हो गया. ठीक है? Now first operation AND will do. Let's see, 1 and 1, 1, 1 and 1, 1 and 1, 1, 1 and 1, 1, 1 and 0, 0, 1 and 0, 0, the other 0, 0, 0. Is the ANDing done right? Getting? अब कुछ लोगों को ऐसा एक क्वेश्चन दिमाग में आया रहेगा. इफ यू रियली यू आर क्यूरियस, तो आप लोग दिमाग में ऐसे लाते हैं कि ये क्यों है ये ऑपरेटर्स, व्हाई डू वी नीड ऑल दिस. These all are needed in encryptions and all, encryption, decryption. Getting? जब डेटा ट्रांसफर करना रहता है फ्रॉम वन रिमोट मशीन टू अनदर, so it is not to be sent directly. The data is to be encrypted, and then the receiving side it is again decrypted. So that time some formulas are used. So that formulas are many times involved with bitwise operator. Not only that, in images, if you want to hide some information, image के अंदर ही कुछ information hided है, getting? तो उस समय भी ये masking unmasking के लिए यूज होता है, getting? So lot of places these operators are used. Is this right? So what will be the decimal of this? इसका decimal क्या बनेगा? 4 and 2 and 1. Will it be 7?
Yes.
Now quickly tell me about ANDing is done. Quickly बताओ. ORing बताओ. 1 or 1? 1. 1 or 1? 1. 1 or 1? 1. 1 or 1? 1. And 1 or 1? 1. बाकी सब 0. ये कितना बनाएगा decimal? इधर तक तो 15 था, 15 में 16 ऐड किया, will it become 31 guys? Just check करो. ये 4, ये रिजल्ट आया ना, तो is it 31 right? Just tell me. 16 and 8 and 4 and 2 and 1 इसका टोटल, तो अभी तक ऑलरेडी हमें पता है 4 ones का 15 और एक 1 जो 16 है, तो 15 and 16 31 ही बनेगा. और लास्ट का XOR बताओ अभी. XOR में 1 XOR 1 0, 1 XOR 1 0, 1 XOR 1 0, 1 XOR 0 1, 0 XOR 1 1. मैंने कहा ना XOR में जब दोनों बिट्स डिफरेंट है तो आंसर 1, एंड जब बिट्स सेम है तो 0. अब बताओगे इसका क्विकली. 16 और 8 कितना? ये 16 और ये 8, तो 16 और 8 का टोटल कितना होगा? 24 ना गाइस?
Yes.
दिस विल गिव यू आंसर 24. तो यहां तो मैंने ये दोनों पॉजिटिव ही लिए थे, इसलिए टूस कॉम्प्लीमेंट वगैरह का झंझट नहीं है. बट ट्राई करो, कभी स्पेयर टाइम रहेगा तो यू ट्राई टेकिंग एनी ऑफ द ऑपरेंड एज नेगेटिव. यू टेक 15 एंड -23, ऐसे करके देखो. एक नेगेटिव एक पॉजिटिव, या दोनों नेगेटिव ट्राई करके देखो. जस्ट फॉर योर प्रैक्टिस, योर कॉन्फिडेंस. ठीक है? Is it clear? Now you can cross verify this answer. 15 and 23. See here, I'm printing 15 and 23, 15 or 23, and 15 XOR 23. Okay, and we have found what as answer? 7, 31, 24. Let's cross verify. Is it right? 7, 31, 24.
Yes.
Okay, so this way you can try for some more examples also. And now remain two more operator in bitwise only, दो और बाकी है. ठीक है? They are called as shift operators. 2 greater than and 2 less than. But remember, these shift operators are having more precedence than those 3 which I told you. Just now that 3 operators which we saw, AND, OR, XOR. These 2 operators are having same precedence, but more than those 3. मीन्स सबसे ज्यादा किसका? वो टिल्ड का है, फिर इनका आएगा, इन दोनों का, देन एंड, देन एक्सॉर एंड देन और. ऐसे याद रखो. इन तीनों का सेम नहीं है. एंडिंग, ऑरिंग, सॉरी, एंडिंग, एक्सॉरिंग, ऑरिंग. Before that this shift operator, and before that tilde operator. Okay, now quickly I'll just tell you in the next session in more detail. We'll see a right shift end time. It is called as right shift, and this is called as left shift. Okay, now that n is called as a shift distance. It is also called as a shift distance. Now what this right shift does, it shifts the bits of a right side n times. Whatever the bits of a are there, okay, whatever bits are there, it is going to shift them right side. Last bit will go out, then second will come at 1 will come at 0, 2 will come at 1, like that. Okay, now you have a doubt what will come at the MSB. The 0th is going out, 1 is coming at 0, 2 is coming at 1, like that. So second last will come at second last. What will come at last? Getting? So I'll tell you about that. And this does the opposite. Okay, here what it does, right, left shift. This is right shift, this is left shift. Here what will happen, this MSB will go out. ये बाहर इसको बाहर फेंक दिया. Second last will come at last, like that. Okay, and 0th will come at 1th. Now again the question, what will come here? जैसे इधर क्वेश्चन है कि MSB में क्या आएगा, वैसे इधर क्वेश्चन होगा LSB में क्या आएगा, राइट? क्विकली याद रखना है, when we do left shift, always in LSB 0 will come, 0. अंदर हमेशा कौन आएगा, यहां से 0. ये सब शिफ्टिंग हो गया, but always in LSB 0, but not same here. Here it will preserve the old sign bit. जो भी पुरानी साइन बिट है वो ड्रॉप होती है, मैंने प्रिजर्व होती है. शिफ्टिंग हो जाएगा, बट एमएसबी पे कौन आएगा, जो पुराना साइन बिट है. तो प्रीवियसली इफ देयर इज 1, 1 ओनली विल बी प्रिजर्व. प्रीवियसली 0, 0 ओनली विल बी प्रिजर्व. ओके, ठीक है. तो इसके ऊपर और डिटेल कल के सेशन में बात करेंगे. राइट गाइस, बट टुडे वी हैव टू स्टॉप हियर ओनली. And then tomorrow some trace output questions. फिर ये मॉड्यूल हमारा वाइंड अप हो जाएगा. This module will get over. Then we have to start with the next module. ठीक है.